Hey, so we are doing problem number 2 from homework number 10. Suppose that x of t is a Poisson process as in the above question, such that expected value of x of 9 equals to 6. Find the mean and variance of x of 8. Find the probability that x of 2 is less than or equal to 3, and find the probability that the conditional probability that x of 4 is less than or equal to 5, given that x of 2 is less than or equal to 3. So let's get started. All right, 1 second. Get my bearings together. All right, so we need to find the mean and the variance of x of 8. It's not too bad. So first we find what lambda equals to. So we have expected value of x of t equals to lambda t. Therefore, the expected value, we have the expected value of 9 is equal to 6, right? So 9 lambda equals to 6. So what is lambda? Lambda is 2/3. So we want to find the mean and the variance of x of 8. Here we have, we want to find x of 8. So we basically just plug and chug. What's 8 lambda? 8 lambda is 8 times 2/3. Expected value of x of t, where expected value of x of 8 is therefore equal to 16/3. Now we want to find the variance, where, sorry, I forgot to write this in. It equals to, let's see, I'm trying to think, variance equals to e of x squared t minus e of x squared. Sorry, this video is going to run a little longer. So we know what this is. We found that in the last problem, and that equals to lambda squared t squared minus, plus lambda t. And over here, this equals to minus lambda t squared. These cancel out. So basically, it just equals to lambda t, which is 8 times 2/3. Again, that equals to 16/3. So there you go. There's the variance, and there's the expected value of x of 8. Part B, we're trying to find the probability that x of 2 is less than or equal to 3. We use a formula, probability of x of t is less than or equal to k, where this equals to the summation from 0 to k, probability of n0 comma probability of n of 0 comma t equals to I equals to the summation from 0 to k equals to e to negative lambda t times lambda t to the I factorial. That it's basically the Poisson equation. Okay, so what do we have here? We basically just plug and chug. We end up with probability of x of 2 less than or equal to 3 is equal to summation from 0 to 3 e to negative 4/3 to the k over k factorial, which equals to e to negative 4/3 plus 1 plus 4 e to the negative 4/3 times quantity of 1 plus 4/3 plus 1/2 times the quantity of 4/3 squared plus 1/6 times quantity of 4/3 cubed, which equals to 0.955. All right, now this is the more difficult part of the question. This is part C. And please feel free to pause the video whenever you are confused. Okay, part C. It's gonna run a little bit long. So we have over here, so z equals to the number of, So yes, z equals the number of Poisson points in 0 to 2. Basically we have to set z equals to z z equals to x of 2, and w equals to x of 4 minus x of 2. As you can see, the z over here and the w, and through, so this conditional probability, this is what it equals to. We know probability of x of 2 less than or equal to 3 is 0.955. We know that part, but we need to find this top part. How do we find it? We set z of 3 equal to some arbitrary value, let's say k, and we set this w equal to some arbitrary value, let's say m, as shown over here. But we have a problem here because 0 and 2 and 2 and 4 are, 0 and 2 and 0 to 4 are overlapping. So that's why we need to set x of 2 equal to z, and w equals to x of 4 minus x of 2. That really is the only way we can sort of solve this problem. So when we do that, we have 0 to 2 and 2 or 4 are non-overlapping. Therefore, z and w are independent. And to find... so basically, we just work it out now, okay? And here, this top part is equal to the summation from 0 to 3, summation from 0 to 5 minus k. Because remember, z is equal to x of 2, where k is equal to this top part right here. So is equal to z, sort of. And that's why we can replace this top part, 5 minus z, with 5 minus k. And so this is the formula that we have from the notes. But however, we have two things that we need to manage. So therefore it equals to e to negative 4 lambda times 2 lambda to the k over k factorial and 2 lambda to the m over m factorial. To solve this, we need to solve this top part over 0.955 right here. So this and this are synonymous, and we end up with 0.967. And that is the end of problem number 2, homework number 10.